And we have, term. Also, I want to point out that this is the beginning of term 2. So in reality, you all start basically with an A. Your homework, your grade for term 2 will basically be based on your homework that is due tonight. So if you don't do your homework tonight, you'll start your term with an F. If you do your homework tonight, you start your term with an A. So come tomorrow, are you starting with an A or are you starting with an F? Will come in terms of just literally doing this one homework assignment. Doesn't mean you're going to get an A or an F, just the reality. Bivariate data. All right. When we say bivariate or bivariant, sometimes we might hear say it's much the same thing. The main important thing is, what are we doing? This is the study of what? The study of what? We've studied, so the study of two somethings. Anybody remember from Saturday from your virtual study sessions what type of variables? No. We've already studied two categorical data. We've already did that in chapter 3. So two quantitative variables. So that's what bivariate data is. And more importantly, we're going to focus on the relationship between two quantitative variables. So it's really, when we say the study, it's the study of the relationship. Okay, so we're going to see how these two variables relate. Categorical data, we already studied those ones. We studied one categorical data. We studied two categorical data. That's when we did the segmented bar graphs. We've studied univariate data. That's when we did the box plots, the histograms, the stem plots, the dot plots, the box plots. Those were all univariate data. Even the normal model is a study of one quantitative variable. But now we're going to talk about two quantitative variables, and we're going to talk about the relationship. And so much of this course, most of this unit, the main focus topic, the essential question, I will say, of this whole unit is to work on how to describe the relationship between two quantitative variables. So that's what the main thing. How do we? I guess you can say, how do we? If you want to turn it into an actual question, how do we describe the relationship between two quantitative variables? All right. Now, in terms of review, when we talked about univariate data, we described the distribution. You were asked to describe the distribution. And when we were talking about, univariate data, one variable, we had our mnemonic device SOX, where we talked about shape, outliers, center, and spread. I talked about in terms of after term 1, and we go into term 2, I'm not going to really be accepting the term 1 material, but we're going to be doing the term 1 material all over again. And more importantly, that if you can't do shape, outliers, center, spread, you're going to have a very hard time, very, very hard time passing the AP exam. Because we're still going to actually be doing that. At times, I might give you two variables, and I might say, for each of the variables, describe the distribution. Or I might give you two very quantitative variables, and I say, for this one, for this variable, what would draw the histogram? Well, you can still do that. You can still do a histogram. You can still describe a distribution for one variable. These are all things we can still do. But that's what we did for our previous unit, right? Units 1 and 2, our main focus was on describing the distribution of one quantitative variable. We also had in there the two categorical variables as well. For our material, you might see describe the association between blank and blank, where this is our first variable, which I'll note as variable 1, and variable 2. Now you should also note that I put in a new word. I substituted in a new word, and what was that word? Association. And so what does association mean? From the context of what I've been covering so far, what does association mean?
The relationship.
Exactly. So these two words for our purposes are interchangeable. Okay, they're interchangeable. The relationship between two variables, the association between two variables. Correlation is a different thing. We'll talk about correlation. It's a very misheard word. That's going to be our focus in terms of almost tomorrow. And in your homework tonight, you'll see me saying ignore any questions that use the word correlation. We're not going to talk about correlation until tomorrow. Correlation is a association and relationship are the same. Okay, they're the same thing. Correlation is a subset of that. In other words, it's a more specific type of association. It's a more specific type of relationship. All right. When we do this, the graphical representation is called a what? Does anybody know what the graphical representation is? So we're having variable 1, this is like your x-axis, and then you have your y-axis, and then you have variable 2. Does anybody know what our graphs are going to look like in these problems? What they're called? No, that's what categorical. Okay, so let me show you a visual. Once I do the visual, you probably remember the name from your previous math courses. You've seen this. Promise, I promise. Now, anybody? Now, does this ring a bell for anybody?
I'm not sure. Is it a dot plot?
No, dot plot is only one variable. You haven't seen it in this course. When I said you, I promise you've seen this. I don't mean in my course. I mean in your previous courses on the MCAS, in middle school. What is the name of this? Give you the first letter. There we go. It's a scatter plot. Okay, so I might ask you to draw the scatter plot. You may have some problems where I'll ask you to draw the scatter plot, and you'll have to label and do all those type of things. And sometimes you'll be given a scatter plot. All right, so our scatter plots are going to be all over the problem. Okay, and we utilize the scatter plot. Remember to do it in regards to the problems. And I also want to, just as a reminder, context is still important for these problems. So we must label. We must also have our scale. And the scales are the x and y, and then you have to have, of course, the data. All right. So now this is not how we describe. This is just the scatter plot. Scatter plots help us to describe. They are not the description. Okay? So don't think if I say describe and you draw a scatter plot and go, there you go, and be like, that's just the scatter plot. Okay. Now that's like step one, and that might be part A. I've seen problems on the AP exam where they ask you to draw the scatter plot because part A of the homework of the AP exam questions are usually give me's, and sometimes they'll either ask you that or it's a very traditional, not trying to trick you problem. But we have the scatter plot. Given a scatter plot, we describe the relationship, the association, by using doofus. This is our mnemonic device. Doofus. You doofus. These scatter plots are doofuses. It's just a mnemonic device. It's something that's an easy word to click into our mind, like socks, like, hey, socks and doofus. So it's D, U, F. Now we've already used the U, so I do it real small, so we're not going to technically use the extra U, S. Okay, each of these, so there's 4 parts, and also remember context. So there's technically 5 things we look at. Just like socks, S-O-C-S, there was 4 parts plus context. In here, there are 4 parts plus context. So, what does the D stand for?
Distance?
No. Good guess though. Most likely you'll only know what these stand for if you attended the virtual study session. And if you're not, we're just learning it right now. It's okay. I saw someone about to talk. No. The first D stands for direction. Okay. There are 2 answers for direction. Your direction can be positive or the direction can be negative. Okay. We'll talk about these in a little bit more specifics. We'll break them down, each of these 4 things, very soon. U. What does U stand for? It's very similar to the other one from socks. I know there's not a U in socks, but it shares a commonality with one of those. It's just another name for it. What do you think we're referencing? I know it's not going to say the letter U, but what do you think we're going to reference? What do you think I'm trying to allude to from socks? It's very similar to outliers. Okay, it's very similar to outliers. We're not going to call them outliers, though. We'll call them unusual features. Yeah, Alexander, you've already, so when you were in my stats class last year, basically what we're doing right now is what you've already done. Ooh, I can't spell unusual. Unusual features, which are just outliers. So why do we call them unusual features and not outliers? Anybody? Why are we referring to them as unusual features then?
Because I think the way the dots go, like, you know how the dots go in the same
You're,
Well, because we're gonna see outliers, we're gonna see like the dog is gonna be far away, so that's like the unusual feature, I guess.
yeah, you're overthinking it. It's because Dofus doesn't roll off the tongue as well, right? It's just a mnemonic device. It's just a mnemonic device. All right. They're outliers. They're unusual features. Even in the other one, we call them outliers. We can call that an unusual feature. Um, it's the only reason that we do not say outliers that you can. It's just because we're using the mnemonic device um, doofus. That's it. That's it. Don't overthink it. Make sense? Think so. F. And these are new letters. This is a new one. Yeah. See, Alexandra, remember she took my non-AP Stat semester course last year. It stands for form. We have two types of form, and that is linear and nonlinear. We can also use the word straight or curved, but we'll typically just stay with the form. There's a linear form. The form is linear or it's nonlinear. And finally, we skipped the second U because that's why we have it in there. What is the S stand for? It's a different S than socks. We want to talk about the what of the relationship, the S of the relationship. Yeah, so strength. Alexandra said how strong the relationship is. So we say strength of the relationship. And there are 5 strengths that we might refer to, and they range from very strong relationship to a very weak relationship. Right in the middle, we call it a moderate relationship, but we might say moderately. Typically, we say moderately strong, but if you just say moderate, there's a moderate strength. That's an ly. In other words, moderately strong. You can say moderately strong. You can technically say moderately weak, but typically it's moderately strong. It's moderate. It's like in the middle. It's in the middle. It's not very strong. It's not very weak. It's in the middle. It's a moderate relationship. And we have also strong and weak. Those are the 5 levels that we would use in terms of describing the strength. We can say this is a strong relationship, or we want to even put it even more because it is. This is a very strong relationship. Or hey, that's a weak relationship. Or you know what? That's not even weak. That's very weak relationship. And then that one's not neither. It's neither strong nor weak. It's moderate. Okay. And just remember context. Always say something like between blank and blank, and where you say what is the first variable and what is the second variable. Just make sure that you include this kind of statement between here and here. You need to say it's so surprising how some people will just list. They just list it. They do doofus and they just list it, and they never say anything that relates to that problem. They just don't say that problem. If you were in my study session, if you were in my study session for the virtual, we studied the relationship between the chirps of a cricket and the temperature. So those were the 2 quantitative variables that we studied, and we talked about, and we could have talked about the relationship and how it was a strong relationship that was linear. We assumed there was no information given there. Since they didn't give us a scatter plot, we don't know if there was any unusual features. But there was also a positive relationship because the slope was positive for the regression line, which we'll get to as our next part. That's actually technically we're in chapter 7 right now, but chapter 7 and 8 I combine into one unit. So 7 and 8 are combined into one, and a little bit of 9 technically. So, first and foremost, doofus. If I say describe the relationship between two quantitative variables, at minimum, or the first thing we need to do and making sure everybody has on board is that we know that we're talking about direction, unusual features, form, strength, and we better include context because it's AP statistics. 5 things that we need to talk about. Doofus is a nice mnemonic device that helps us remember what those 4 features, the 4 parts are, and then of course context, because everything should include context in the AP statistics in your description of anything in the real world. But direction, and these are sometimes the easiest questions on the AP exam, because it's, when I say easy, when you either get it or you don't. That's what I consider easy. I don't consider easy in regards to like, oh, that's easy, you should just know that. I'm saying easy in regards to you either know it or you don't. Okay, so you either know what the question's asking and what and how to and know how to answer it, and it'll just come and then either get full credit or you get no credit. So these are the types of problems that if they show up on the AP exam, you better get you better get full credit if you expect to pass the exam. So because you either know it and you know what it's asking and therefore you should know how to do it, or you're going to be like, well, I don't even know what it's saying. I don't know. And mostly that's going to come from not doing homework if you don't know. All right, that's the truth of the matter, and that's why I put so much emphasis on it. And as since we're doing remote learning, why I have to put so much more emphasis on homework and the daily, stuff that we're doing more so than I would in the past. Okay. So let's say we were given this. So you were given the following scatter plot. Plot does not have an E. Okay, so we're going to use this for the rest right here, the scatter plot. So um, I'm going to now. I'm not going to put the other parts in there because I'm just going to redo, but I'm going to at least screenshot this part right here because in the notes part I want to refer to this one. We're going to go over each one of them. All right. So here is our scatter plot, and like I said, in the context of this problem, we were studying the relationship between the temperature in degrees Celsius and the number of chirps from a cricket that occurred that were recorded within a 15-second interval. All right, so this was done many times in the problem from the virtual study session. There was 20 data points, so we collected the data 20 different times at various temperatures. Doesn't mean they were always different temperatures. You could technically be taking a temperature at the exact same one. So for example, right here, both of these are taking that temperature at the temperature being 12. All right, so remember, it's not an exact. The whole focus here is we're modeling, And we have to understand, and in statistics, there's always this concept of variability. And so we want to describe the relationship. Okay. So when talking about direction, all right, when talking about direction, we said that there's either positive or negative. So if the scatter plot goes up, and so we often, what we'll do is I like to draw with this little cloud, this cluster of data. Okay, the cluster you can see is going up, and so we would say that this is a positive direction, versus if the cluster of points goes down, this would have a negative relationship. So this has a positive relationship or a negative relationship when we're talking about the direction. So in our problem here, what is the direction?
Positive.
It's positive. Okay. So that's direction. The next one is unusual features. An unusual feature is any data point that does not follow the trend / cluster of data points. So when talking about, there's technically two types of outliers, okay? So let's say this is our data points. We can have an outlier that's completely out of the plane. So here are my cluster is really right here. I don't want to include that other cluster because that data point shouldn't just shift everything. And so we can have an outlier that's like this, or we can have an outlier that's like this. So this is an outlier out of the trend. And this right here is just an outlier in path. And we'll have more specific names for these when we get into the course of trend, but far away. So those are both outliers. In this problem here, do we have any unusual features?
Yeah.
Yes. And so the answer is yes. And so we would want to do it, and it's around, we would say 8, it's like around 8 comma, like 26. That point right here, I would say that this is this point, and I always want to point, I would say that's around 826. That's an outlier. So I'll just make note of it. Okay. Form. Okay, the form, remember, there's either linear or nonlinear. It is the relationship of the cluster. Do not take into account outliers. If the cluster is oval-ish, then we say linear. If it is non-oval, then we would say non-linear. Okay, so in this cluster of data, I can see that's very ovalish, right? Circularish, right? Circular is oval. But in this one over here, you see how there's that curve to it? More like a pickle, or however you want to describe it. It has that curve. It's not just a straight oval. This is what we refer to as a linear, and this would be nonlinear. What do we get in our picture here?
It's linear.
Yeah. You can overall see that if I just take the data right around here. Now that point that's outside, I do want to point, we got this one right. I wouldn't call this an outlier, even though I'm not kind of utilizing it inside my oval. But you can see that this one's clearly far away. That's clearly an outlier for the other one. You know, I would consider this to be relatively linear because I can, you know, if you think about the data, for the most part, it follows along some type of line. So this kind of, the data follows some type of line. Oh, sorry, down here. The data follows along some type of line, but over here, you can see that the data doesn't really follow some type of line, which we call the regression, the line of best fit, the least squares regression line, as we'll be learning throughout this chapter. And finally, strength. Strength is a measure of predictability to future / past points, or you can think of it as the tighter the oval, the stronger the relationship, where vice versa, the more circular, the weaker the relationship. The tighter. Okay.
What does it say after tighter?
The. So if the points look like that, and on the other spectrum, right here, and if I were to think about the cluster of the data points, I also want to point out that strength and form doesn't matter. So both of these over here, I would refer to as very strong. Both of them. This one, the top one is very strong and linear, positive, very strong linear. The bottom one is positive, very strong, nonlinear. Okay, so the only difference between the two on the right is its form, linear versus nonlinear. This one over here, I would refer to as very weak. Okay. And of course, you got to do it in a range of spectrums. Very rarely will you say very weak or very strong. Typically, you want to just use the strong to weak. And if you're kind of like in the middle ground, I think it's strong, but it could be weak. But I feel more confident that it's strong than use the word moderate, if that's the case. All right. And so there's a spectrum around here. Um, you know, typically things that are moderate just don't have a lot of data points. So I always think about it as, can I predict where the next point would be? So if I had to put a point right here and I had this X value right here, where would the next point be? It might be here, it might be here, it might be here. I really don't know where I'm supposed to draw that next point, or where if I had another data point. I don't feel very confident about where it would be at all. That's very weak. Over here, I would think that anything around here would probably be around pretty good. So that's probably why it's moderate. We're over here, right there, here, right there. I'm very confident the next point will be right around somewhere around in this region or somewhere right around this region. Or over here, I think the next point is somewhere around here. And over here, I really have no clue where that next point would be. All right. So I like to think about predictability, or you can think about it as the cluster, the strength of the cluster. So what do we got here? What do we got here for the strength?
Very strong.
I wouldn't argue with it, but I'd probably just go with strong. I'd probably go with strong. Strong to very strong would be acceptable answers. There's a lot of little gray area. There's a wiggle room here for strong. But here's the thing. Typically on the AP exam, if you're off, if you say very strong, but it's moderate, you're going to get no credit. If you say strong and it's moderate, typically you get credit. If you're like 1 degree off, you have that. And so unless it's like there's no doubt about it that it's very strong, no doubt about it, try to use strong. And then we finished the problem in terms of the answer. There is a positive, comma, linear, that should be an R, comma, strong relationship between degrees, and I will say, between temperature and chirps. There is also an outlier. Sorry. Should I say there is an outlier, or should I say, what should I say? There is an apparent possible outlier at 8, 26. Almost every time on the AP exam, you're not going to get an outlier for the actual question. So this is what my answer looks like.
Do every time we get an outlier, we have to say the point is at?
You should always try to. All right, you should always say name it or do something in regard to that. All right, your homework. So that's your introduction to this part. We'll get in terms of it a little bit more. The last thing I want to make sure as you're leaving, before you leave, I just want to say that if there's an association, and I'm going to repeat this, does not mean causation. Just because there's a relationship, and I'm going to talk a little bit more about this, doesn't mean that it isn't cause something to do. And I'm going to show you a nice picture tomorrow. There's lots of memes behind association and causation. I'll show you some of those tomorrow, but I want that as its own focus as we get tomorrow. Do your homework. If the question talks about correlation, ignore it. It is time for class to end. Get your homework done. Start with an A in term 2. And of course, pass term 1. Turn in your quiz, exam. Get it all done. Any makeups by Friday. Have a good day.